Hello and welcome to video 2 of Learning C Programming for Beginners. So you create a C program file. I like to call it main.c because there is a main function in C programming, and a C program has an entry point, or the C program entry point is the main function. So I just call it main.c, but you can call it anything. So let's edit the file, and we'll enter in that same old hello world that we did last time, and then go from there to cover all of these basic structural basic components, or whatever you want to call it, basic things you need to know to code in C. Alright, so hello world, as we had before, was as follows. So this is that same code from the first video. So we're going to compile it, and then we'll put it in one command to compile it and execute the executable, and we get our hello world. Okay, so data types. First thing is data types int and float. We'll start with int. Int a equals 11. Int b equals 5. So here, let me do it this way. Alright, so here, variable declaration of type int. Let me increase the font. There we go. Variable declaration of type int. Assignment to variable. One-liner. Variable declaration and assignment. Alright, now let's do some arithmetic. Int c equals a divided by b. Oops. And let's look at the result. For printing, as we had hello world, we just printed a string. Hello world. This is called a string literal. String literal. So this gets, when you type this here, the compiler is gonna extract that and put it into memory. So somewhere in memory is going to be this string, and then when we print it, it's going to be hard coded to print this out. But when you want to print variables, then we're going to have to use placeholders, and each placeholder, so we're done with that, each placeholder requires a format specifier. So we got placeholder. That is also a format specifier, and so for a decimal, an integer, which is a whole number, is also in math called a decimal number, I think. Well, anyways, it's %d. I'm not sure about the terminology, but %d is the format specifier. So it's holding a place here, and then you add a second argument, and you get you put in your variable that you want to be printed in this placeholder. And since this is a %d is for integers. With %d, this a must be an integer as it is. So we're okay. Everything's correct. And we run it, and we get the 11. So let's see the result of our arithmetic calculation. So we'll go %d equals %d. So you can do multiple here. You can do A and B, and then the result is C. So this A corresponds to the first %d, this corresponds to the second %d, and the C corresponds to third. So that's how it works. So if we have 3 in here, we have to offer 3 here. Otherwise, it won't print out whatever. If you only had 2, this one here would be empty because there's nothing there. Alright, so let's look at the result. So we get 2. Now, as mentioned, it does integers or whole numbers. So if you divide 11 by 5, 5 goes into 11 twice, so you get 2. And then that remainder 1, we can get that also. And remainder equals A, and for that we use modulus. So there is, in computers they have division, and they also have modulus, which will give you the remainder of integer division. So let's see what the remainder is. R. Oh, forgot the F. So it's a good idea to take a look at this. Implicit declaration. So this means, this print, it doesn't know what that is. So it's saying that it's thinking that this is well, we'll get to that later. But that was the error, the F there. So we corrected that, and we get remainder 11. Alright, we did integer division. Now what if we wanted to, when do you often do, you don't often do integer division. You when you do 11 by 5, you want the decimals in there too. So get rid of the modulus, and we'll switch things up and do more useful arithmetic. For that we need to use decimals. So we have a floating point type. We had integer, which did whole numbers, but now we want to get the decimal or the fraction, so we got to use floating point number type. So we had integer float type, and now we have floating point type. So floating point just refers to that decimal that might be wherever it is. So we'll make this one float, and we'll make this one float. And also here, instead of %d now, we gotta use %f format specifier. So we'll change these to F. And now we should have a decimal. There we go, 2.2. And there's a lot of zeros there. So in a format specifier we can get more specific about how we want the format to look like. And here we'll say just putting 0.2, it says use just 2 decimal points. There we go. So for accounting, you're usually going to want to use 2, and there we have 2. In this case we don't need 2, we probably just need we don't need maybe 0. I'm not sure, never tried 0. See if that works. But 2.2, we don't want the 0, and we don't need to see the 11, 0, and 5, 0. So there we go, we get it like that. Okay, so we did integer and floating. Now we're gonna do casting. C is loosely typed, so we can change type on the fly using casting. And you'll see in a minute why I put casting in brackets. So let's go back here, change this to an int, we'll change this to an int, and now we're going to try to do float of 2 ints and see what we get. So these now are d's, because we changed it back to int, and the answer, we're hoping still to get a float somehow, but we won't. So we see we get a float, but it's not the correct number. So this is an int, and an int is resulting in that 2 that we had before, and then when it passes it to here, that 2 becomes 2.0, so it becomes a float but not the correct number. So the division wasn't done with floats, division was done with integers. So what we can do is just simply cast it. Now this a that was an int has been changed to a float, and same with the b. Now when we divide, we get the correct number, 2. Oh, maybe I didn't save it. Yeah, I saved it. Int. That should work. Oh, I didn't compile it. Did I? 2.0. Oh. Okay, that's weird. I thought that worked. Let's see. Oh, yeah, here I gotta change the ints to float. And we got, now we got a float. So it converted it and did the proper calculation for us. Okay, so we did int and float types. Now we'll do arrays. Int list size 10, or let's do size 4. You have to, this is how you specify that you're going to have a list or an array, and then see they call them arrays. It's just a list, and you can, when you declare an array and initialize it, you would use square brackets, braces like this. So that's 4 numbers, 0 to 3. They start at 0, so there we go. We got, oops, and we got our array. Otherwise, if we didn't do that during instantiation, we can't use the braces. Those braces, we can only use it when we declare it and then assign it. So we could do if we do it after the fact, then we have to go one by one and set the values. And here, just for convenience, I'm matching the indices to the values, but obviously this side must be 0, 1, 2, 3. There's no that's fixed. If we have a list of 4, then the first one is 0, second one is 1, 2, 3. Indices 0, 1, 2, 3. And then here, this is what we'll hold in the list. A was 11, say, oops, A was 11, here we have B, say, 5, and we can have a list of numbers, all arranged neatly from 0 to 1. 0 to the size minus 1. 4 minus 1. 4 is the size. The last indice is 4 minus 1, which is 3. Okay. Now we'll do loops. So let's say we did want to go like that. 1 list 2 equals 2. So often you're going to come into, you're going to write code that is going to do something, you know, predictable like this. So instead of typing it manually, what if this was 10? Oops, if it's 10, it's going to go to 9. So in that case, what we can do is use a for loop. So here's what a for loop looks like. For initialization, so we start at I equals 0, as array start at I equals 0, and then the length, so let's put it int size equals 10, and we'll put here size. And now we can go here and put size minus 1. Oh wait, no, less than size, we don't have to do minus 1. Less than size, and I plus plus. So I plus plus is increment, obviously. I plus plus, I equals 0. I plus plus, this is the same as going I equals I plus 1. Okay, so that's done. Now we're going to go list I equals I. And okay, so later on we do some stuff. Later on we want to verify or check or print it out or whatever. So we'll repeat it. And now we can do printf %b equals %b, oh wait, list. So make it look nice for readable. Put a new line after each one, and I, and list of I at I, and print it out. So here we set them to 0, 1, 2 all the way to 9, and now we're going to print it out. Next we printed it out, and now let's test it out. And there we have it. So 0, 1 to 9. So that's loops. Another way to do loops that you see common, mostly for loops, you can pretty much always use for loops. But there's another way to do it, and that's the while loop. Whoops. While loop, while, and we'll put here 1. In computer programming, 1 equals true, 0 equals false. So here we got 1, so this means this is always true, so no matter what it's going to run. And then what we'll do is we'll say if I is less than size, is greater than or equal to size, then break. You don't write break. You don't write that. You just put break. So here we have this operator, greater than equal to. So we have greater than, less than, greater than equal to, less than equal to, and or. So you could say if. You can say while 1 or 1. Or you can go while 1 and 1. So that means both of the either or both. So that's a basic concept in programming. So I'm just running through this quick. I'm not giving like a detailed lesson for learners. This is just like just you want to see it quickly, and then whatever interests you, spend a little more time on it. But there's tons of other stuff that you will see in other places, and I'm going to skip a lot of it. So if you follow along with me, I can save you a lot of time. But depending on what your goals are, I'm trying presenting things in a as briefly as possible, and using just that brief set, I'm going to try to show you a lot of cool things, hopefully in the near future. Okay, so we got these two. Now next comes, okay, so we did loops. Now we'll do pointers. Okay, so here we have size. Now what if we want to, well, we saw list. List is a great place to start with pointers. So we saw list. Now instead of using indices, list is actually a pointer itself. So what that means is when you have size, this word size is saved in memory. We basically, computers are just ones and zeros, as you know. Ones and zeros, and then 8 bits. A bit is a 1 and a 0. Usually 8 bits makes up what they call a byte. So let's say we're dealing with 8-bit bytes. So this size is stored in a byte, and then that size will point to the memory address, and that memory address will hold a 10. Now with list, this one is many ints, 10 ints in a row. So here we just have 1 byte, and now here we have 10 bytes, and they are sequential. So they come, so if however your memory is, you're gonna have memory like one byte, and then it's gonna be all ordered, and it's gonna go up to 1 billion. Like we have 1 gig of this is just 1 byte. Kilobyte is 1,000. A megabyte is 100,000. A gig is 1 million. So this goes on, and each of these have addresses, and so here size is stored with the address of where this 10 is stored. So we got 3 bytes being used. Lists, similarly, is going to be the data that's stored in lists. Like here we have 10, and then here, if we had stored, we did our for loop. Okay, so 0 to 9 and so on. All of these are stored sequentially in memory. So this list is going to point to the first one, and then the rest are calculated as an offset from 0. So this is 0, this is 0 plus 1, or this address, whatever address is here, this one is going to be that address plus 0, that one, the next one is going to be that address plus 1, and so on, all the way up to your size. Here it's only 10, but it could be much bigger size. So it's a pointer. And now we're going to see how to actually the pointer part is hidden from us. We don't really see what's going on, and a lot of programs don't even bother with it, but C does, and it lets you do. It's interesting, and you can do some things that sometimes it's more convenient to use pointers to do things. So let's see how pointers work. So we got a pointer, and to use it, you got to put a star. It's called a dereference operator. Dereference operator. So this is a reference. Size is a reference to a memory address. List is a reference to a memory. Size is a reference to a memory address. Pointer, on the other hand, is dereferenced. So it's not pointing to a memory address. It is a memory address. So to set it, we can just do list. First one. If we try to just, as I mentioned, this one is already a pointer. So before we work, I mentioned that, let's just do int size pointer, and then size pointer equals and size. So we use the address operator, and that says, don't give me the value 10 at size, give me the address that size is holding. So like I mentioned, that size is stored as a variable name, a reference name, to an address, and then taking that address, we get back the 10. So now instead of copying 10 to size pointer, we're saying copy the address. So let's print now size and print out size and the pointer address size, and look at the result. So size, and we don't want to, we're going to dereference because we want to see the value pointed at. We don't want the address itself. So let's run that code and verify. We're expecting to see both of them having the same value because they point to the same memory. And let's verify that they point to the same memory by there's a memory address. You probably never use it besides learning, but there's %p for printing memory addresses or pointers. Memory addresses. We got .p for pointer. When you want to print the pointer and not the value, put that. And maybe we have to put an and, so we don't want to do reference now, we want the actual pointer. And this one is already a pointer, but since it's been it's not technically a pointer, you got to put the address operator. And here we go, they're both pointing to the same address. And we can verify one more time. We'll change size to 25, and we'll print again the values, and we see they're both 25. And we'll do it the other way too. We'll go size pointer, and we'll make this one 50, not forgetting the dereference operator, because now we're changing the value being pointed to. And we'll print again, and we see they're both 50. So we see how pointers work. Now getting back to pointers of arrays. Say we want a pointer to this array. So now we go int, since it's an array, wait, let's make a pointer list. Oh, we'll get to pointer list after. Pointer and pointer equals and list. Okay, so it's already, we don't even need the and, but it's okay to put it. It will allow it, and we want to, let's just try it like that. And it's going to give us an error. We want to see the error. So we got an int pointer. That's our int pointer over here, and then here we have an array, int pointer array. So that's a problem. So what we got to do is go like that. Now we have it. We have a pointer to the first element, which is pretty much the same thing as I mentioned earlier. So let's no errors there. It compiled okay. So let's do something interesting. As I mentioned, there's some interesting things you can do with it. So we did a for int, oh wait, hold on, int I. We did I equals 0, I being less than size, I plus plus. And print okay, so we're back to printing 0 to 9. Oh, we made a mistake somewhere. Oh, we didn't fill it up first. We gotta set it. So we'll just do it in one go. We'll do it as we fill it. So I, and so we got 0 to 9. Now let's move this here. It's weird if we do it in the same. Then it's like, what's the point? I mean, now if we do it separately, then it makes more sense. What did we, that you know, we filled it up and now we're looking at it. When we fill it up and look at it, it's like, obviously it's going to be what you just filled. But this is supposed to be like some other time. Like, you wouldn't actually fill it and print it. You might fill it and then later on or fill it, like depending on what your situation is in the code. But you'll see that in the future when you start coding. Okay, so we filled it up and we printed it. Now we're going to try to do the same thing using pointers. This time we want the value, and then each time we're gonna push the pointer forward. Okay, and let's get rid of this one so we don't have it twice and get confused about which one we're looking at. Okay, so we got it once, and see, just the same way we printed out the pointer, and we didn't use any okay, let's change this actually. Pointer I, put an I here, and pointer, and we'll put pointer, because we're not using the previous way, we're doing it a different way. Okay, so instead of using indices, we had the pointer pointing to the first one, then we can increment it and it'll point to the next one, and we see that it worked just the same. And the cool thing is that it doesn't matter if it's bytes, this could be a float, and even though the memories might be just 1 byte apart, it'll still automatically do the correct offset. Let's print the addresses too now. Did we print the addresses? Okay, let's print some addresses so we can see the addresses. So and here we're going to put address and P, and then pointer. And so we see 4 apart. Now let's change it to floats, so we can see that even though the size is different, it still increments it fine. Oh wait, oh, not the int. Is that it? That's all we need to change to float? And we gotta change the format specifier. Oh no, that one is still gonna be a P. Okay, so now our list is floats. So these ones are 0, 4, 8, 4 bytes apart. I think that's bytes, should be. Now we're using float. Oh, we made a mistake somewhere. Oh yeah, this one doesn't need to be. We just needed to change these two. This one and this one, the list and the pointer. And it's still 4 bytes. Maybe I didn't save it. Well, I guess floats, and I wasn't going to mention double, but this is like making a really big number. So I guess floats and ints are pretty much same size, which is weird. I didn't expect that, but we can demonstrate it. Hopefully we'll see. Now doubles are 8 apart. So these, remember, here we were 4 apart, and now we're using double precision, so it's a big number. It leaves a lot of space. It allocates a lot of space for your number. Double precision, and now it's going 8, double the amount. Okay. So that's pointers, and now we're gonna do characters. Now, just like numbers, a list of numbers we have here, we're gonna see a similar thing for strings. Strings are character arrays. First, let's look at character type. Char equals, and let's make it A. So how you do that, notice here, single quotes. So when you're declaring a character, a single character, you would use single quotes. And not necessarily single, there's some single characters that are escaped, like null character, this one. It's 2 characters, but that's still 1 character. Tab character is another one. New line is another one that we saw with the print statement, print function, printf statement. So those are 2 characters, but that's counted as 1 because this backslash is escape character. So it means don't interpret this as a 0, don't interpret this as a T, don't interpret this as an N. It'll look up in a table and say, okay, 0 maps to null, which is a special character. T maps to tab, which is a special control. You know what a tab is. And then N maps to new line, which we know what it is. Okay, so we got that character done. Now if we want to make an array of characters, we have to do them one at a time. So character my char array, let's say 10, or we can leave it empty. and fill it up. And now we're going to use double quotes. My char array. So let's print this one out and see that we're doing okay. For this, we use %C for a character and my char. And here, my char array. Here we use %S for string. My character array. So we covered %D, %F, %P, which you never use, it's just for learning. But D and F you're gonna use, and C, it's rare you're gonna print a character, single character, but sometimes. So you got %C and %S you're gonna use a lot. It's mostly printing strings. Okay, so let's take a look. And there we go. It prints fine. Okay, so one trick about arrays, I'm not sure if I mentioned it when I covered arrays. If you go int my num or any array, my array, and we fill it up like this. The compiler will add in here. Oh, sorry, I forgot the brackets. Okay, the compiler will fill in here size 4 for you. But if you don't, then you have to put in the 4. But if you're, like I mentioned, declaration and initialization, if you're going to initialize upon declaration, then you got this shortcut that you can do. And in addition to that shortcut, you can omit this too. But otherwise, you have to include it. So that applies to character arrays too. So here we go. So we did this, but now we're gonna do it a different way. My character array. And now we'll count it out. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 long. We go 10, and character strings are terminated by a null terminator, and I'll show you that in a minute. So here we're up to 10. The count is, sorry, well, when we're counting, we're going to go from 1. So the count is 11 plus the null terminator. Oops. Oh crap. Plus the null terminator, which I mentioned. So that makes 11 plus 1, 12. So here we need to put 12. For the most part, it will even do that for you. But other times you will need it. So remember this null terminator. So here we'll put that, and we can add the null terminator or omit it, and either way it will be included. My char, and we're going to print that now. Okay. Now what if we want to change this now? Or what if we wanted to just have this here and then maybe add my... What I'm trying to say is that just like with numbers, how we were able to just do that shortcut with the braces, here this is also a shortcut. But we couldn't do char, my char, and we could omit this as a shortcut to this size. It'll get filled in automatically. But what we can't do is go like this and then go. Sorry, I forgot the. Although it doesn't matter what you name it, it's up to you. But I'm just being consistent. You can't go like this after you've declared it. You can't do my char array. That won't work. That's not how it's working, because this my char array, as we mentioned when we looked at arrays, it's just a pointer to the first memory address. So, you can't copy a full string to the first memory address. You need to copy M to the first memory address, Y to the second one, a space to the third one. So if you were going like that, then you'd end up having to do something like this. 0 equals single quotes for a single character, my char array 1 equals Y, and all the way through. Y space, we gotta put a space. So here we got my, here space, here C, and so on. You get it, my char array, all the way, and then finally a null terminator. So you can't do that. You have to go one by one, as you did with the number integer array or any array. So you have to do that same thing with strings. Okay. So the best way to work with strings is as follows. There's like lots of tricks and shortcuts, and but if when you're new, you just do the basic way, and then you won't have stress or worries. It won't be tricky. Most of the stuff is just tricky optionally, but you can skip the tricky stuff and just do it the easy way, and then you never have any problems. So for the most part, if you're gonna have a string that never changes, my string constant. There's a constant keyword, but this is already constant. My string constant. And that's it, nothing else. You don't have to do anything. You don't have to worry about memory. You just have your string, and then you can print it. Anytime you want to print it, you can print it using %s. Okay, but if you're going to have a string that might change, you want to use the same variable but have a changing string, set it to one value, something happens, set it to another value. Sometimes you might want to do that. It's not a real good reason, but it might happen. So when you have a string that you want to change, then you're going to want to use a buffer. So instead of using the pointer first you create a buffer. So string buffer, call it. You can call it anything. We're going to call it string buffer. Give it a size that's big enough for sure, and then make a pointer to it, to the string buff, and set it to the string buff. Oops, forgot the star. And now you've got your now with the string pointer, there's you can pull in another header. So this is a good time to get into headers. So strings transitioning into the next topic of header. This standard io.h here, this one is this print function here, that is included in this string, this file. So this is basically C code that we include in our file, and when we include that, then we can print. So let me show you what happens when we don't do it. My char array, my char array. Okay, so my char array prints fine. Now we delete this one, and there we go, implicit declaration. It doesn't know where this is coming from, like I mentioned before. So put that back in there. Now there's another one. There's tons of them, but here's another one. Pretty much the second most common one for a C programmer. You want to work with strings, you got to use strings. This comes with the library of functions. So we go C code. You can see everything in here. String.h, and here it is, a reference to all of them. Library functions. We got string concat, memory copy, all these string functions. This is the probably most common one. String length. Get the length of the string. And where's the string copy? String copy. So when you're gonna use your buffers, and then instead of going one at a time, 0, 1, 2, or using pointers and incrementing in for loops, that's all done for you in this code, and you just use it. So you just put in your destination here and your source. So let's copy a string to a buffer. So like I mentioned, it's a good idea to just make string buffers. Buffer 100. Let's call this one string buffer 1, and we'll make a pointer to it. Pointer to string to buff 1 equals string buff 1. Get rid of this. And 2, make another one. This one we'll call it buff 2. This pointer to buff 2, buff 2. And now we'll go string, copy, and then the source will the destination is going to be pointer to buff 1, and we'll put in a sample string test, string copy test. And now that's done, we'll do similar thing here, except here we have a string literal. Get rid of that string literal, and we'll put in, oh wait, we'll put it in here. We're going to copy, this is buffer 1, we're going to do to buff 2. So we're going to copy buff 1 into buff 2. So here we can print off pointer to our string buff 1 %s, new line, string buff 1. And after we make our copy we copied string literal to the buffer 1, now we're copying buffer 1 to buffer 2. So change this to 2, and this one to 2. And let's make sure we see a sample of string copy test twice. And there we have it. So that's string buffers. And so we did headers, string buffers. Now we'll get into functions. As I mentioned in the beginning, the main function is your initial program entry point. When the program is compiled, it's designed to start from here. And we can make our own function. So let's make our own function. Int our own function. We'll call it function 1 because I'm going to make 2 of them. Or I'll give it a different name. Alright, so our own function. Let's copy all this over there. Put it in here. And then in here, just go our own function. And we have a okay, I'll mention that in a bit when the compiler gives us an error. So what's the point of moving it here and into our own function, into its own function? Well, now we can have 2 of these, and then instead of having this mixed in with another one, even though they're separated, I mean, we could put them in, we could put comments. Okay, so let's call this one, let's just make 2 so I can demonstrate the idea. Our own function, and we'll make another one, and let's just copy, we'll just do the first part. Call this one another function. Put this here. Okay, so another function. And all this code now has been encapsulated into a block. This is another block, and they're separated and neatly organized. And then when we're set with this, we can forget about it. We're set with this, we can forget about it, and just focus here. So it breaks down the problem into components and makes solving a big problem into solving a set of smaller problems. So now we're just working with these two lines instead of this 2, 4, 6, 8, 10 lines. Instead of managing 10, we've broken it up into 6 and 4 and 1 and 1. So you can see the advantages. So that's functions. Well, there's more to do with functions still. We haven't run it, so let's run it. and we're going to see the return problem. So okay, so it's our own function. We didn't change that. This one here, we're going to put another function. Otherwise, can't really see what's going on. Can't verify that what we're doing and expecting is happening. So there we go, another function. So that's happening as we wish. Okay, so now that that's done, we can do the return type. See, we have a return 0. 0 is an int, and here we have an int. So in C, you're gonna put. So I'm gonna put arguments. This here should come after functions. So return and arguments. That's that. So we're going to return, then we're going to get to arguments. So this one is int here. So the int is going to return. The main is returning an int, and the value is 0. So when we run the code in Bash, you can do an echo, and then I think $, question mark. And that'll give you the return type of the previous program executed, which is our program here, right here, which is returning 0. So there we go, we got 0. Let's change that number to 5. Well, you won't see people returning 5. You see often they're returning -1. So let's do a -1. That means something went wrong. Anything other than 0, something went wrong, but let's compile it now. And it ran. And let's see the return value of the most recently executed program, and it's 255. I'm not sure why that happened. Maybe because it's negative. So let's put in 1, or let's put in 5. So I guess it can't be negative. You can have negative up here, but not in the main. And we got 5. Okay, so that means there's different types, and some types don't allow negative. So we're just we don't have to cover it, but we did int and float, and then we tried to skip double, but I had to show you anyways. And then within that, there's like unsigned int, signed int, but we're gonna skip all that. It's mostly useless unless you're getting into porting to different operating systems and more advanced stuff. But here we're just returning 5. Okay, now these functions also returning stuff, so let's return stuff here too. So return. If we reach this point in the line, no errors happen. If we put we can put if flow control in our code, and then say if this happens, return this. If that happens, return that. And then over here, we can test the return value, which you're going to see in a minute. But we're not going to do all that returning. I'm just going to quickly show you how to do the return. And then as we get later on, if it comes up, we'll use it. I don't think it's going to be a long time before we ever have to use any, so you would go int return value. Often you'll see people using RET, so I'll use RET. RET equals, and then you would go, they would do it in a 1 line, but I'm going to do it in 2 lines. You go return, if return. And then do printf error our own function. Else no error. So if we return 0, that's false. So if it's anything other than 0, this is going to run. I'll show you that in a minute. Error our own function. So right now, our function is returning 0, which is false. So if false means this line doesn't execute, and then otherwise this one will. So let's run that. String buffer, another function, no error. Now let's say we had some flow control here, and then we wanted to return. Here we say if, let's say this string copy was of our own making, and we had some return there, then we can do if and I'll just put here true. But we would have a return. This one, string copy, it's not going to fail. If we fail, it's not string copy's fault, it's some other mistake. So although it does have a return, nobody bothers with it. We all skip it. So we'll put here return 1 or -1. We can use -1 here. Return -1. So here we're gonna put, we want to see the -1 too. So we use braces since we got multiple lines. And then we'll put here, we'll put the error code %d and return. Okay, so now this line is never gonna run. This line is never gonna reach this point. It's gonna exit right here. So we get no error. I returned -1. Maybe I didn't save it. There we go. Whoops. 0. Return. Oh, it's another function. So let's move this one here. Okay. So another function, calling that, and let's see how it goes. And now we do have an error. Error, our own function code -1. Here we return -1. So that was non-zero, which is true. Anything other than 0 is true. So this line executes, and we read, and it prints this value. And then if we get rid of that, do it again, although we already saw that, and we see no error. So it reached the bottom and returned no error. So if it's false, it doesn't execute this line. Else gets executed, no error. So that's a return and a little flow control. Now there's arguments. So let's just do to this one. Okay, let's get rid of all this. We don't need that anymore. Change this to 0, and let's pass an argument. So we want to pass. Let's pass instead of copying this. Let's pass in a string, character, message, and another function. My message. And there we go. Oh, something's missing. Where's that? Line 26. Line 26. Oh, we forgot to copy it. Okay, and then we're going to copy that message over to string copy. And now we got my message. So that's how easy it is to pass a character. This could be anything now. But we have to be mindful that since this is a message, the string copy needs a character pointer. So it works. If we pass an int here and then we try to pop it in here, obviously that it's not going to work. And we'll get an error. And you can pass multiple. So let's put in here int size. And let's put in int size, or we'll make it a different name just for demonstration purposes, that it is not the same, it's getting copied over. So size, and then here we'll put size, and hopefully there's no errors. So let's see, and no errors, everything works fine. Print the size out, allocating buffer of size %d, new line, size, and let's see that we passed it, 100, size of 100. Okay, so that's passing arguments, function arguments. One more thing that's important to know before we get into multifile is this is above main. So when we get here, another function, and we already have this saved. Another function is already, when the way it works, it goes in order. When the compiler starts making whatever it does, it goes this one first, then this one. It doesn't execute it in order necessarily, but it processes it in order, and it can't process it if it doesn't. Well, I'll show you what it can't process right away. Right now, if I take this and I move it to the bottom, now when we're here, it hasn't processed this yet. So the compiler is going to complain, say, what is this? I don't know. Oh, I didn't save it. So just like we had the implicit declaration, we have that same problem again. Just like when we didn't include string, then we didn't include studio, standard IO, then we couldn't use print, or if we don't include string, we can't use string copy. Now, since this is below here, we can't use our own function and another function because it's not, the references are coming too late. So we have to make sure that these come in beforehand. So the easy way is what we were doing. We put them first and we put main at the last. But next I'm going to show you multiple file system, in which case, you know, it isn't going to be in the same file, so it won't have any. We're going to need to do what we're about to do right now either way. So all you got to do is just type in int our own function like that, just like we do here. We're telling it, this is called function prototype, and we're telling the compiler that this function that we're going to operate, it's going to return an int, and it takes no arguments. You can put in void here. Void means 0, so you can just leave it blank and put in void. If you for return type, you can't leave it blank. If you have a function that doesn't return anything, we'll do that right now. Another function, let's say this one doesn't return anything. In that case, we'll put in here void. And we could put void here too, or we can leave it out. So that's our own function. Now the next one is another function, int another function, and here we gotta put in the arguments too. I'll put that. So now the computer is aware that another function returns an int, and it expects arguments. The first of which is a character, pointer, and then the second one is size. You can leave out this because it doesn't need to know those names. It just needs to know it's an int and a character pointer. But they say it's better to put it, if you're reviewing the code and studying it and want to look at things, and it's more convenient to have that in there because now it's a little more meaningful. So okay, this another function takes the message and the size int. If it was just character string and just int, then it has no meaning. Besides, it's a memory allocation size. Okay, so we put the prototypes here, and before it wasn't working, but now that we have the prototypes, let's see if we have the implicit declaration error. What did I do wrong? Something's wrong here. Int our own fund. Int another fund. That's good. Our own fund. Another fund. I don't know. 20, line 20. Oh, you know, here we forgot to put void. So we changed this to void. So even though it's spelled the same, it has a different function prototype or signature. Sometimes they call it signature having specifying the return type and the function arguments. It gives it a special signature, and since it didn't match, it looks like it's a different function. So we gotta make sure those match. And wait a minute, still an error? Did I not save? Void, yeah. Maybe we gotta put in, no, we don't have to put void in the arguments. It's just the return type was the problem. And so it's good, it compiled. Next, okay, so we did return and arguments. Now we got multifile, directories, and scoping left to do. I don't think we're gonna get to scoping, but we're gonna do multifile and directories for sure, because the video might get too long. So let's close this up, and we're gonna make multiple files. So cp main.c to func1.c and another let's see. Okay, so now we have 3 files. So we'll put in this file, we'll just have main and these function prototypes. And this file isn't printing, or it's not using strings, so we can get rid of these 2. And delete these. Oh wait, before we delete these. We don't need these. We're gonna have them coming from separate files. Now this one, the other files. This one, let's do another func. So this one's another func, and that was the main. That's the main stuff. Our own func is another file. This one's another func. So there's another one. Save that, and we'll do the third one is func1. So this one doesn't need these. That's for the main function. That's gonna call here. This one, and delete that. Okay, so here's our setup. Put the longest one, main here. That's the longest function. Save, change, yes. That's main. And here's func and another func. Alright. Squish it up a bit so it fits. You can see it all. Okay, so there's everything. All split up. So these are still there. But instead of these 2 functions being below or in the same file, they're in separate files now. And we have studio and string in both of them, but the compiler will take care of it for us. It won't get included twice. But we need to include it twice. If we're using it in this file, we need to include it in this file. Okay, let's compile. Now to compile, we just like we did GCC main. Oh, we're gonna save all. We'll just do write all. Okay, so that saves them all. And func and another func. It compiled, and it's running just as before. So that's that. Multiple files. We can move it into directories too. We can say make dir live. Move func. Oh, before we move it, better close it. Move func to live. Move another to live. And now we'll do gcc main.c live func live another func. And just as before gcc. Oh yeah, it worked. And there we go. A.out. We did it. If we didn't, another shortcut. If we didn't move it into file. Move live. We didn't move it there. We just had it beside main. Then we can do the shortcut. Just do star.c. Pause everything. Yes. Okay, so that's multiple file and directories. Scoping. Okay, let's quickly do scoping. Gvim star.c. I'm going to do scoping really quick. It's important to know that variables within this function are not available in variables of another function. So main can access int size, return. That's it. And another function can access character string, these two these two variables, these two data types or data instantiations, but they can't access between them. And also, if you put something here, like we had another function here, or let's just make another function, int third one, and so we'll just delete this, and we'll get rid of this. We don't need this. Okay, so between files is obvious. Okay, stuff here, anything here, that's variable. It's 10. And get rid of that. We'll put these two. We'll get rid of that. Use that. Okay, so I'm just setting up a different setup. And x equals 9. And global. Naming it the description. This is a global space variable. Okay. So int x is only available inside. Let's make this void. We don't need that. Void. So int x is only available here. Over here we can't see it. And size here is only available here. Over here we can't see it. This can be seen here and here. And now between the files we can't see anything. This is global, but only global in this file, but it's not going to be available here. But we can make it available by using extern. So I'll show you extern really quick. So we're going to use another function, get rid of this. And so this test is available in this file, but not in this file. That's file separation. Global space, this one here, is available to anyone in this file, but it's not going to be available here. So, but here we have global space. What we're going to do is right in here, extern int global space variable. Now, and let's get rid of this. We're not going to use that. No, for this example, we don't need to see it. Get rid of that. And let's change this one, void, another function, and empty that out. Put in void. Just, we don't have to, like I mentioned last time, but here I'm doing it just so we can see the syntax styling, how it's expected to what you're supposed to be filling. We didn't use void, so now we see it as an argument. Okay, so extern int global space variable. Let's see if we can print it. Actually, first let's see not being able to print it, and then we'll add that and then print it. Well, we don't want to do both of them this time. We just want to do main, and we want to do another. Oh, see, global space, error global space undeclared, first used in this function. So that's a problem. So if you wanted a variable here and then there, and you didn't want to pass it through as a function, or for whatever reason, for the most part you never need it. It's not good practice. But it'll come a time when you're gonna need it. So here's how you do it. Extern. try again. And it compiles. And if we run it, we should see extern as we have that printout. Where's the printout? Oh, we didn't call it. We gotta call it. Another. Alright, now we're calling it. And there we have extern 10. So it works. And that's everything for this video. I hope you guys liked it. And hopefully I'll make some more videos, and hopefully you guys watch some more videos. And